Imagine a world where genetic diseases can be edited out of existence, where the very fabric of human evolution is rewritten at will. This world is no longer a distant dream, but a reality brought to life by CRISPR technology, a revolutionary gene editing tool that emerged just over a decade ago. In 2012, scientists unlocked its potential in bacterial cells, but by 2018, this powerful technology took a controversial turn when a Chinese researcher introduced genetically edited babies. This shocking development ignited fierce debates. Should we play God with human genetics? Fast forward to today, CRISPR is projected to address 90% of genetic disorders, potentially benefiting millions. Yet, with great power comes immense responsibility. The societal implications are monumental. Will we enhance human traits, or will we create a divide between the genetically enhanced and the natural? As we explore the remarkable capabilities and ethical dilemmas of CRISPR, one question looms: how far are we willing to go? CRISPR, the revolutionary gene editing technology, has radically changed our understanding of genetics since its inception. In 2012, scientists Jennifer Doudna and Emmanuel Charpentier made a groundbreaking leap with the first successful application of CRISPR-Cas9 in bacterial cells. This breakthrough opened the doors to targeted gene editing, showcasing CRISPR's potential far beyond its natural role as a bacterial defense mechanism. The story took a human turn in early 2013 when the first use of CRISPR in human cells marked the transition of this technology into the realm of human health. This shift was not just scientific, it was a watershed moment in biomedical history. By 2015, researchers announced that CRISPR could be harnessed to treat genetic diseases, indicating a future where inherited disorders might be eradicated. The excitement was palpable, yet the ethical implications were becoming increasingly complex. In 2016, Chinese scientists took a controversial step by editing the genomes of human embryos, igniting a worldwide debate on germline editing. The idea of altering the human gene pool raised immediate questions. Should we intervene in human evolution? What responsibilities do scientists hold? Fast forward to 2018, when He Jiankui announced the birth of genetically edited babies, an event that sent shockwaves through the scientific community and prompted global discussions on the morality of playing God. By 2020, CRISPR-based therapy was no longer a distant dream. Zolgensma became the first approved therapy for spinal muscular atrophy, proving that these innovations could indeed have life-saving implications. With an estimated 2 million people worldwide potentially benefiting from CRISPR therapies, the stakes are high. However, as we navigate these advancements, critical debates linger. Proponents view CRISPR as a democratizing force that could make treatment accessible to many, while opponents warn of widening healthcare disparities. Balancing the promise of genetic innovation with ethical considerations is paramount. Today, the relevance of our choices in the face of CRISPR's potential echoes louder than ever, inviting us to ponder. What future do we want to create, and at what cost? As we examine the implications of this technology, we must ask ourselves, how do we ensure that CRISPR serves humanity's best interests and does not lead us down a perilous path? On July 3, 2012, a scientific breakthrough occurred that would change the landscape of genetics forever: the first successful application of CRISPR-Cas9 in bacterial cells. This discovery wasn't merely an academic achievement, it was a monumental shift that demonstrated the potential for targeted gene editing. CRISPR, originally a defense mechanism in bacteria against viruses, had transitioned into a tool capable of editing genomes with unparalleled precision. But why did this happen? The answer lies in a growing need for innovative solutions to address genetic disorders and diseases that have plagued humanity for centuries. Fast forward to January 30, 2013, when researchers took a monumental step forward by using CRISPR in human cells for the first time. This pivotal moment marked a transition that highlighted the versatility and power of CRISPR technology, moving it from the confines of microbial defense to potential therapeutic applications in humans. Why was this leap so crucial? Scientists were driven by the alarming statistics. over 13% of the global population carries heritable genetic conditions, and nearly 90% of genetic disorders could potentially be targeted by CRISPR. The urgency to mitigate these suffering conditions fueled rapid advancements in CRISPR research. By April 1, 2015, the conversation had expanded. Researchers announced that CRISPR could potentially treat genetic diseases, paving the way for its clinical applications in medicine. This heralded a new era of hope for the 2 million people worldwide estimated to benefit from CRISPR therapies for genetic disorders. The combination of scientific ambition and pressing medical need created fertile ground for CRISPR's explosive growth and acceptance. However, with opportunity comes caution. On April 21, 2016, Chinese scientists ignited a fierce ethical debate by editing the genomes of human embryos. This event exposed the dual-edged nature of CRISPR technology. While it holds the promise of eradicating hereditary diseases, it also raises ethical questions that could redefine the boundaries of human intervention in natural evolution. Why did this create such controversy? As these discussions unfolded, they highlighted a crucial divide. Proponents argued that germline editing could prevent hereditary diseases, while opponents warned of unintended consequences and the potential for designer babies. The stakes escalated in November 2018 when He Jiankui announced the creation of the world's first genetically edited babies, sparking international outrage and ethical backlash. This shocking revelation underscored the necessity for global discourse surrounding the regulation and ethical implications of genetic editing. In essence, Jiankui's actions forced the scientific community and the public to confront uncomfortable questions about the power and responsibility of wielding such technology. Yet, despite this turmoil, progress continued unhindered. On July 1, 2020, the first CRISPR-based therapy, Zolgensma, was approved for spinal muscular atrophy. This approval demonstrated not only the practical value, but also the safety of CRISPR in treating genetic disorders, providing a model for the future of gene therapies. By June 30, 2021, CRISPR successfully treated beta thalassemia in patients, offering tangible evidence of the technology's humanitarian potential. In examining these developments, we see a clear cause-and-effect chain. The advent of CRISPR technology led to an increased understanding of genetics, which in turn opened doors for targeted therapies. However, this narrative is not without its tension. The debates around germline editing, access to CRISPR therapies, and the regulation of genetic editing illustrate the ethical mazes we must navigate. As CRISPR's capabilities grow, so too does the need for robust discussions surrounding the moral boundaries of science. The future of CRISPR carries implications that reach far beyond the lab. It questions the core of what it means to be human. What can we learn from this unfolding narrative? The trajectory of CRISPR serves as a crucial case study on the balance between innovation and ethical responsibility. We are tasked with asking the right questions, ensuring that advancements are accessible to all, not just a privileged few. As we reflect on these developments, the global conversation surrounding genetic editing continues to evolve, demanding that we meticulously consider both the promise and the peril of this revolutionary technology. Will we embrace it as a tool for healing, or will we tread too far into the unknown, risking unforeseen consequences? As CRISPR technology gained momentum, it unveiled a landscape fraught with complexities. The promise of eradicating genetic diseases quickly collided with ethical dilemmas that left scientists, ethicists, and society at large grappling for clarity. In 2016, when Chinese scientists made headlines by editing human embryos, the scientific community erupted in heated debate. Could we, as a species, responsibly wield the power to edit our very essence? The conversation intensified further in 2018 when He Jiankui made a stunning announcement. He had created genetically edited babies. These twin girls, whose DNA was modified to confer resistance to HIV, sent shockwaves around the globe. Critics cried foul, branding it as reckless experimentation that could pave the way for designer babies, a dystopian future of genetic privilege. Meanwhile, proponents insisted that the ability to eliminate hereditary diseases was a moral imperative. With every new development, the stakes rose higher. The crux of the debate revolves around germline editing, the practice of altering genes in embryos that would pass those changes on to future generations. Proponents argue that eliminating genetic disorders could spare millions from debilitating conditions. Yet, opponents cautioned against unintended consequences. What happens to the natural course of evolution? Will we inadvertently select for traits that may have unforeseen implications on our genetics and health? As the ethical ramifications simmered, the field saw a striking rise in clinical trials. From 2015 to 2021, the percentage of clinical trials utilizing CRISPR technology surged by 37%. Researchers began employing CRISPR in studies targeting conditions like sickle cell anemia and beta thalassemia, making remarkable strides. In 2020, Zolgensma, the first CRISPR-based therapy, was approved for spinal muscular atrophy, demonstrating the therapeutic potential of this technology. However, while some celebrated these breakthroughs, others raised red flags about access to CRISPR therapies. With a projected market size of $4.2 billion by 2025, the question looms: who will benefit from these advancements? Will the promise of CRISPR democratize treatment for genetic disorders, or will it deepen the divide between the wealthy and the underprivileged? Access to such transformative therapies could become a privilege rather than a right, becoming a new frontier of inequality. The need for equitable distribution of CRISPR technology has never been more pressing, especially considering that 13% of the global population harbors heritable genetic conditions that may be targeted by CRISPR. As we push the boundaries of genetic innovation, the regulatory landscape remains contentious. Some advocate for strict regulations to prevent misuse, fearing that without safeguards, CRISPR could be wielded with reckless abandon. Others argue that overly stringent regulations stifle innovation and discovery, slowing the momentum of a potentially revolutionary scientific progress. The balance between safety and innovation is a tightrope walk, where one misstep could lead to catastrophic outcomes. As the scientific community grapples with these pressing issues, one thing is clear: the future of CRISPR doesn't just lie in its remarkable potential for altering genes. It also rests heavily on the ethical considerations we must confront. The implications stretch beyond the laboratory and into the very fabric of our society. Questions of genetic privacy are on the rise. As we unlock the secrets of our genes, how do we ensure that this information is handled with care? The looming specter of genetic discrimination casts a shadow over the potential benefits of CRISPR. How do we safeguard against its misuse, especially in a world where genetic information could determine access to employment, insurance, and even social standing? The technology that holds the key to curing diseases is also a double-edged sword, demanding our ethical vigilance. With so much at stake, the narrative of CRISPR is not merely one of scientific advancement. It's a profound moral journey that challenges our understanding of what it means to be human. As CRISPR stands on the precipice of transforming human evolution, the questions we face today shape the future of our species. Will we harness its power for good, or will we allow fear and misunderstanding to dictate our choices? The climax of this story hinges on our ability to navigate this complex ethical landscape. Are we prepared to meet the challenges of our own making? The consequences of CRISPR's rapid development are profound and multifaceted. Since the first successful application of CRISPR-Cas9 in bacterial cells in July 2012, the landscape of genetic science has transformed at an unprecedented pace. By 2013, CRISPR transitioned into human applications, allowing researchers to manipulate genes with remarkable precision. This leap sparked hope. Could CRISPR treat genetic disorders once deemed incurable? In April 2015, researchers announced the potential for CRISPR to tackle genetic diseases, setting the stage for a new era in medicine. However, with this power came controversy. In 2016, Chinese scientists took the bold step of editing human embryos, igniting a firestorm of ethical debates. The question loomed large: where do we draw the line between medical necessity and moral hazard? The revelation was startling. While CRISPR could potentially eradicate hereditary conditions, it also opened the door to unintended consequences, including the prospect of designer babies. Could humanity wield such transformative power responsibly? The climax reached a critical point in November 2018 when researcher He Jiankui announced the birth of genetically edited twins. This shocking development sent shockwaves through the global scientific community and beyond. It wasn't just a scientific achievement, it was a stark reminder of our ethical responsibilities. The backlash was immediate and intense, highlighting the fears that genetic editing could lead to unequal access and societal divides. Imagine a future where the wealthy can afford enhancements while the less fortunate are left behind. By 2020, we saw the fruits of CRISPR's promise materialize with the approval of Zolgensma, the first CRISPR-based therapy for spinal muscular atrophy. This marked a turning point, not only proving the technology's efficacy, but also demonstrating that CRISPR could change lives, potentially for millions. Estimates suggest that 2 million people globally could benefit from CRISPR therapies, addressing an astounding 90% of genetic disorders. The implications are staggering. Could we potentially eradicate some diseases in our lifetime? The consequences extend beyond individual therapies. A 37% increase in clinical trials from 2015 to 2021 reflects an urgent race to harness CRISPR's capabilities. Companies like CRISPR Therapeutics are at the forefront, racing to bring innovative treatments to market. Yet, amid this progress, a critical debate arises. Will these advancements widen the healthcare gap? Supporters argue that CRISPR has the potential to democratize access to treatments, while critics warn that disparities might deepen. As we ponder these shifts, we must also confront the reality of genetic privacy. The more accessible genetic information becomes, the more we grapple with who controls our genetic data. In this new landscape, the ethical implications are vast. How do we protect individuals from misuse of their genetic information? The allure of genetic enhancement remains a myth that persists in public discourse. Currently, CRISPR is primarily employed for treating diseases, not enhancing human traits. However, the line remains perilously thin. What happens when the technology progresses beyond its current applications? Are we prepared for the societal ramifications of such advancements? As we navigate these complexities, the landscape of biotechnology regulation becomes paramount. Striking a balance between innovation and safety is crucial, and public concern drives these discussions. The call for stricter regulations is countered by those who argue that excessive oversight could stifle groundbreaking discoveries. Where do we go from here? It's a pivotal moment in human evolution. The choices we make today will resonate for generations, shaping not only our health, but the very fabric of society. Surprisingly, CRISPR is not the end of genetic science, but just the beginning. As we stand on the brink of a new genetic revolution, one question looms large. How far are we willing to go to redefine what it means to be human? The answers will shape our future, for better or worse. The journey of CRISPR technology has taught us more than just the mechanics of gene editing. It offers profound lessons about our place within the natural order and our moral responsibilities. One key insight revolves around the nature of genetic mutations. While we often think of mutations as harmful, the reality is more nuanced. Some mutations can confer advantages, helping species adapt over time. This raises the question: if we indiscriminately edit genes, could we inadvertently remove beneficial traits? As we've seen with past interventions in nature, such as the eradication of certain species which had unforeseen consequences, the genetic landscape is a delicate web. By learning from these precedents, we can approach CRISPR applications with caution and respect for the interdependencies of life. Another vital lesson lies in the ethical implications of our choices. The announcement by He Jiankui in 2018 about genetically edited babies sparked outrage, but also vital discussions about consent, safety, and societal ramifications. It reminds us that while technology can empower us, it carries the weight of moral responsibility. The biomedical community must prioritize ethical considerations alongside scientific advancements. This mirrors historical cases like the Tuskegee syphilis study, where medical ethics were ignored, resulting in irreversible harm and a lasting distrust in medical institutions. What can we glean from these events? Ethical oversight is not just regulatory red tape. It is essential for maintaining public trust and ensuring that scientific progress benefits all of humanity. Moreover, the CRISPR debate has revealed the complexities of accessibility in healthcare. As we project a $4.2 billion market for CRISPR therapies by 2025, we must ask, who will benefit? This is reminiscent of the introduction of life-saving medications in the past, which often widened the gap between the wealthy and the underserved. Ensuring that CRISPR therapies do not follow a similar trajectory is crucial. We need proactive policies that promote equitable access to avoid creating a genetically privileged class. Finally, the dialogue surrounding CRISPR emphasizes the importance of public engagement in scientific governance. A well-informed populace can advocate for ethical standards and influence policy, leading to a balanced approach to innovation. As we stand on the cusp of redefining human health and evolution, we must harness these lessons, marrying our scientific ambitions with a commitment to ethical responsibility. Are we prepared to take that step together? The future of human evolution hangs in the balance, and the choices we make today will resonate for generations to come. Why does CRISPR matter today? The question reverberates through laboratories, boardrooms, and ethical debates worldwide. As of 2021, the global CRISPR market is projected to reach a staggering $4.2 billion by 2025. This technology is no longer a distant promise. It's transforming medical landscapes and offering hope to millions suffering from genetic disorders. With an estimated 2 million people worldwide poised to benefit from CRISPR therapies, the stakes have never been higher. Yet, as we race into this genetic frontier, we must confront the shadows it casts. In the wake of the controversial announcement by He Jiankui in 2018, where genetically edited babies were created, a new urgency for ethical guidelines has emerged. The uproar underscored the critical need for regulations that protect against potential misuse while fostering innovation. Can we strike a balance between allowing scientific exploration and safeguarding humanity from unintended consequences? This conversation is more vital than ever as the approval for CRISPR therapies accelerates. Current events, such as the recent successful treatment of beta thalassemia using CRISPR, demonstrate tangible advancements in real-world applications. However, these breakthroughs prompt fresh ethical discussions. Do we risk creating a divide between those who can access these life-saving technologies and those who cannot? As healthcare professionals advocate for democratizing treatment, critics warn of widening societal gaps. The very essence of what we deem ethical in genetic engineering is under scrutiny. As we look forward, the landscape of human evolution could be reshaped dramatically. The potential for germline editing opens the door to eradicating hereditary diseases, but at what cost? The debate is fierce. Proponents argue it could eliminate suffering, while opponents fear it may lead us toward unforeseen societal consequences. Our choices today may pave the way for a dangerous future or a more equitable one. We stand at a crossroads where genetic editing could redefine health and evolution itself. The choices we make now will echo through generations. CRISPR presents both a beacon of hope and a Pandora's box of ethical dilemmas. How we navigate this intersection will determine not just the future of medicine, but the fabric of society itself. As we forge ahead, are we prepared to uphold the responsibility that comes with such immense power? The journey through CRISPR's evolution reveals a technology poised not only to heal, but to redefine the very fabric of humanity. With its origins in bacterial defense mechanisms, CRISPR has transformed into a revolutionary tool, enabling targeted editing of the human genome. This shift marks a significant milestone. However, the ethical dilemmas it presents are equally profound. Consider this. We stand at a crossroads where the potential to eradicate genetic diseases and enhance human capabilities is balanced against the moral responsibilities that come with such power. Can we ensure that these advancements benefit all, rather than create a new class of genetically enhanced individuals. As we have seen, the stakes are incredibly high. The announcement of genetically edited babies in 2018 sparked outrage, highlighting the urgent need for ethical guidelines. The debate continues. Should we prioritize innovation over moral concerns, or should caution reign as we proceed? The promise of CRISPR is undeniable, presenting a potential market size of $4.2 billion by 2025 and the chance to address 90% of genetic disorders. Yet, with great power comes great responsibility. How do we navigate the nuances of genetic privacy, healthcare accessibility, and biotechnology regulation? The answers we carve today will echo through time, shaping not just our future, but that of generations to come. As we embrace this technology, let's challenge ourselves. What legacy do we want to leave? The choice is ours, and with it, the power to influence the very essence of what it means to be human. The future